Okay, so we doing more examples of limits. We'll consider the following few examples, and then let us start with the first one. Okay, so really the first one, we can evaluate the limit as x approaches 0 of 1 over x root 9 plus x minus 1 over 3x. Of course, by trying to plug in, we will not succeed. Well, I mean, we can explain, we will see more reasons later. But, I mean, now what we can do is put everything under a common denominator to clean that term up. So I'll multiply the first term on top and on the bottom by 3. And I will have to multiply the second term by root 9 plus x. Oops, put a minus here. And then I can proceed by putting everything under one fraction. Now, of course, notice here that if I want to evaluate by plugging in, I get an indeterminate form. So the top will go to 0 and the bottom will also approach 0 as x approach 0. So I have an indeterminate form here that I wanted to get rid of. And one way of getting rid of that determinate form is by multiplying by the conjugate of the term on the top. Of course, I should multiply both the numerator and the denominator by that conjugate. And now what we can do is, oops, this is a different color. Let me get that back here. Well, if I expand that, that's what we get. 9 minus 9 plus x, or we can just write minus x here, right? By just, if we expand this, we can do it on the side. This expansion here is 9 minus 9 plus x, which is minus x. So it's minus x times 3 plus root 9 plus x. Of course, I can cancel the minus x's out, the x's out. I'm left with minus 1 on the top. 3 times 3 plus square root 9 plus x. And that limit can be evaluated directly by substituting x equals 0. So what do we get? We get minus 1, 3, 3 plus 3. Did we miss anything? Let's see. So it's 1. So, okay, I forgot root 9 plus x, right? Yep. And then times 3. So it's minus 1. So it's 9 times 6 minus 1 over 54. Okay. Well, let's do one more example. The limit as h approaches 0 of 1 over 2 plus h minus 1 half. The first thing would be to try and plug in. Well, the top will go to 1 half minus 1 half, which is 0. And the bottom will obviously go to 0 as h gets close to 0. So I do have a 0 over 0, which is an indeterminate form. Here, well, I mean, I can try to clean up the numerator by figuring out the common denominator, which is in this case 2 times 2 plus h, and most likely give me something nice. The whole idea here, as in the previous example, is to get rid of that indeterminate form. Okay, so now I'm noticing that dividing by h is multiplying by 1 over h. And then notice that 2 minus 2 plus h, that would be equal to minus h, 2 over 2 plus h times h. And I mean, I can cancel the h's out. I'm left with minus 1 on the top. It's minus 1, 2 plus h. And that limit can be evaluated by substituting the value h is equal to 0. So it's 1 over 2 plus 0, which is minus 1 over 4. Okay, let's move on to another example. Limit as x approaches 2 of x cubed minus 8 over x squared minus 4. First, we try to substitute. So on top, what do I get? 2 cubed minus 8, which is 0. And on the bottom, I get 2 squared minus 4, which is also 0. So it's an indeterminate form. And the goal is try to get rid of that indeterminate form. Of course, that can be done by factoring x cubed minus 8 as a difference of 2 cubes. So this is x minus 2 times x squared plus 2x plus 4. And the bottom is very easy to factor. This is just x minus 2 times x plus 2. The x minus 2 goes away. And what we get, x squared plus 2x plus 4 over x plus 2. Let's see what that is. This is 2. That limit can be done by evaluating. Let's try to evaluate by plugging in. So this is 2 squared plus 2 times 2 plus 4 over 2 plus 2. So this is 3 times 4 over 4, which is just 3. Now let's do this one. This one is also easy. So it's h minus 2 squared minus 4. Of course, let's try to plug in. H is equal to 0. Evaluate the limit using the limit laws. I get 0 over 0, which is an indeterminate form. This is clear. So I really have to get rid of that indeterminate form. Luckily enough, it's not very hard here. I can just expand the square. And notice that the 4 will cancel out. The limit as h approaches 0 of h squared minus 4h over h. Of course, here you really didn't do anything. I mean, we did something is that we tried to cancel, to cancel the 4 out, but we still did not get rid of that indeterminate form. So here, if you plug in, you still get 0 over 0. So really what we can do here is factor an h out over h. And what we're left with is that the limit as h approaches 0 of h minus 4, which is minus 4. Here is another one. 2 minus root x over 4x minus x squared as x approaches 4. Notice here the top will approach 0. That's 2 minus root x is 2 minus root 4, which is 2. And the bottom will as well converge to will go to 0, right? 4x minus x squared. This is 16 minus 16, which is 0. So I have a 0 over 0 as an indeterminate form. So I really have to work around that. Now, one good way to do or to approach this question is by multiplying by the conjugate of 2 minus square root x on top and on the bottom, right? Like this. Multiplication by 2 plus root x will get rid of the root x on the top part, and on the bottom, when x is close to 4, this term will be close to 4. So this is not a big deal. It's not a problem. Let's see what we get. So let's do that. This is 4a squared minus b squared. It's 4 minus x. 4x minus x squared. I gotta fit this. Well, this is not very hard. 2 plus root x. And now let's pay attention that I can factor an x out from the denominator. What happens here? This is 4 minus x. And then what do we get? Well, the 4 minus x goes away. I can cancel that out. And then what am I left with? I'm left with limit as x approaches 4, 1 over x2 plus root x, which can simply be evaluated by plugging in 4 for x. So I get 1 times 4, 2 plus 2 is 4, 1 over 16. Okay, we have one more here, which may slightly be harder, but not that much. I have the limit as x approaches 0 of x over root 2 plus x minus root 2 minus x. First, let's try to evaluate by plugging in, see if it works. I get 0 on top, of course, and on the bottom I get 0. Why is that? Because I get its root 2 minus root 2. Right, as x approaches 0, root 2 plus x minus root 2 minus x will approach root 2 minus root 2, which is 0. So I have an indeterminate form. Here, what's the best way of proceeding? Is try to get rid of the square roots in the bottom. And how do I do that? Is to multiply top and bottom by root 2 plus x plus root 2 minus x. Of course, this will help me immensely. And notice that the term in red, oops, I have a plus here, so no minus. The term in red will approach 2 root 2, so it won't give me any trouble. So let me do that. So now then let me do this. So I get 2 plus x minus 2 minus x. So what do I get? I get the limit as x approaches 0, x square root of 2 plus x plus square root of 2 minus x over 2x. Now I'll be a bit fast and cancel the x out. And notice that this limit can be evaluated by simply plugging in the value x equals 0. So what do I get? I get root 2 plus root 2 over 2, which is just root 2. It's very important. Now let us look at the following example. Root 6 plus x minus 3 over root 1 plus x minus 2 as x approaches 3. Let's try to plug this in to evaluate by plugging in using the limit laws. The top, what will the top approach? It will approach 6 plus 3 minus 3, which is 0. And the bottom will approach root 1 plus 3 minus 2 as x approaches 3, which is also 0. This is root 4 minus 2, and this is root 9 minus 3. So 0 over 0, which is an indeterminate form. Here, of course, it's the old conjugate trick that will come in handy. Let's try that. Of course, I mean, here we'll have to apply it on the top and on the bottom. So here I just rewrote this. Now, I gotta multiply by the conjugate of this term This will get rid of the square root on the top. Now, in order to get rid of the square root on the bottom, I have to multiply top and bottom by root 1 plus x plus 2. Now notice on the top, I better not touch this term. This term on the top should stay fixed. And on the bottom, this term on the bottom should stay fixed. Whereas these two should be expanded in order to get rid of the square root that is bothering me. Expand. Right? The idea here is that this one, this way, will be very helpful in getting rid of the square roots in an efficient way and not add terms that are, that are not bothering me. So let's do that. What do we get? We get 6x, 6 plus x minus 9 times root 1 plus x plus 2. Now, on the bottom, 6 plus x plus 3 times, what is that? This is 1 plus x minus 4. Notice here in this configuration, I can cancel. Well, let me rewrite this down. This is here is x minus 3, square root of 1 plus x plus 2. And in the bottom is square root of 6 plus x plus 3 times x minus 3. So really, this helped me in canceling the x minus 3. And then this gave me a nice limit, which can be evaluated by simply plugging in x equals 0, x equals 3, sorry. So what do I get? I get root 4 plus 2 over root 9 plus 3. So it's 4 over 6, which is 2/3. Thank you, everyone, and I hope it was helpful.